money.
No!
We had to find our velocity equation, so we used the derivative, and here's our answer. And if you move over here, you can see that this is the graph of our first derivative, which is velocity.
Okay, so we have to find the initial velocity for this one. What we have to do is just plug 0 into it, and if we look over here, the y-intercept is our initial velocity.
For C, we had to find the acceleration equation using the derivative, so here's our answer, and over here you can see that that's the graph of acceleration.
Okay, so we have to find acceleration at t equal to 3 seconds, and we just plug in 3 into the acceleration equation, and we got 30 centimeters per second squared.
So at t equal to 3 seconds, the object is accelerating at 30 centimeters per second square.
For part D, we have to find the speed, which is at t equals 1 second. So we did the whole process of absolute value of velocity, and we got 1 centimeter per second. So if you look over here at the velocity graph, you can see at 1 second, the velocity is -1, but speed, since the absolute value velocity, would be 1. So that's how we know it's 1 centimeter per second.
So for this one, we have to find when the person is moving to the left. And doing so, we know that velocity is less than 0, and finding the critical numbers, we can graph this out, and it's positive and negative and positive. And on the graph, you can see it's right here. Before this point is positive, and then between these 2 points, it's negative, and then it's positive again.
This is the part of going into the left to the negative direction.
For step G, we had to find the displacement between time equals 0 seconds and time equals 2 seconds. So we found that the displacement is 2 centimeters. And if you look on the graph, the starting point at t equals 0 and the end point at t equals 2, even though it looks like a lot of distance covered, the difference between the y values of the start and the end is only 2 centimeters.
This is t equal to 0 seconds. The object moves. This is t equal to 2 seconds, and the displacement is 2 centimeters.
Okay, so for this one, we have to find the total distance between t equal to 0 and t equal to 2 seconds, and we have to keep in mind of the critical number. We find the total distance equal to 6.151 centimeters, and yes, the distance covered between this point, and it's basically the whole line.
This is time equal to 0 seconds. And this is time equal to 2 seconds, and the entire distance covered from the very beginning, including the direction change all the way to the end, is 6.151 centimeters.
For step I, we had to find when the velocity is decreasing. So we know that means it has to have when acceleration is less than 0. So with the number line, we found that velocity decreases at whenever the time is less than 1/2 second. So then if we go back and look at the graph, you can see that at any time less than 1/2 second is a decreasing velocity.
Okay, so for this one, we have to find when the speed is decreasing, and speed decreases when VT and AT have opposite sign, and we use the number line, and we got this answer. And if you look over to the graphs, then you're going to see that before this point, velocity is positive, and after this point is positive, but in between those two is negative. For this one, but before 1/2 is going to be negative, and after it is going to be positive. We just have to look for when they have opposite sign, and we find the answer.